Hi, my name is Maddie Gaines, and this is my Physics 2212 Lab 3 Magnetic Field of a Bar Magnet. The purpose of this lab was to measure the distance dependence of the magnetic field due to a small bar magnet. Calculate the distance dependence predicted by the equations for the on and off axis magnetic fields derived from the Biot-Savart law using GlowScript, and compare the measured values to the predicted values of distance dependence. The principles include magnetic field and superposition. The magnetic field describes the influence and force experienced by charged particles, currents, and magnetic materials in the presence of magnetic fields. The principle of superposition states that the magnetic field at a point due to multiple sources can be determined by summing the individual contributions of each source in all directions. The formulas used throughout this lab include the Biot-Savart law, the magnetic field formula, magnetic dipole moment, magnetic field of a dipole, and magnetic flux density throughout the center of a loop, on axis and parallel. So our results were that our n was equal to negative 2.96 meters, and our dipole moment was equal to 3.18. We found out that our magnetic field was equal to 4.81 to the negative fifth in our experimental setup, and 2.19 to the negative fifth in our GlowScript model, which showed that our GlowScript model produced a smaller amount of magnetic field than the actual amount. Our observations included that there was a near zero magnetic field in the x direction when our magnetometer was super far away from the magnet, and that the x component increased as distance between the magnet and magnetometer decreased. We assumed that the bar magnetic acted as a magnetic dipole in order to apply the Biot-Savart law for the experiment. The system was the bar, and the surroundings were everything else. The initial conditions were the bar magnet and the magnetometer on the phone. For the details of the experiment, I first found the location of the magnetometer on the phone by sliding my phone perpendicularly to the axis that the ruler was on, both vertically and then horizontally, with the bar magnet on one end of the ruler in order to see at which position of the phone relative to the magnet the strongest magnetic field was being read. Then I placed a piece of tape at the location in order to pinpoint the exact location we moved. On the main experiment, we first had to orientate the phone so that the x component of the magnetic field was zero, ensuring the Earth's magnetic field did not interfere at all with the bar magnet. The on-axis distance from the bar magnet to the magnetometer was found using the ruler for several different magnet values. These values were then linearized by taking the natural log of either side and then graphed for part 2 of the experiment. We found the off-axis magnetic field of the bar magnet. We did so by first finding the on-axis distance from the bar magnet on the phone such that the net magnetic field was 100 microteslas. Then we slid the phone in the vertical direction in the same distance and recorded each component of the net magnetic field at this location. The y component of the magnetic field to the bar magnet was found by subtracting the Earth's contribution to the y component from the total component of the magnetic field. For our calculations, we found the slope and intercept by taking the ln of k, and we also solved for the dipole using the magnetic field of a dipole formula, and we found our output was 3.18 am squared. For our data analysis of the off-axis, we found our average magnitude of the magnetic field to be 4.81 to the negative fifth teslas, and we used these calculations throughout previously stated in the lab. So this is our GlowScript model for calculating the perpendicular magnetic field, and we can see that our magnetic field was smaller using the GlowScript model compared to our experimental model. So like I previously stated, we saw that our GlowScript calculations gave us a smaller magnetic field than our actual calculations, and we likely think this is because there's discrepancies in the GlowScript model because it doesn't account for external electric fields. There also could have been errors made by us during our own calculations, like rounding errors or just doing the experiment incorrectly with the bar magnet. If I instead laid out my meter stick at some intermediate angle with respect to Earth's magnetic field, our magnetic north would act on the x and y components, and the contribution of that would then depend on the angle, and that would have therefore changed our results. So if instead I used the two identical magnets stuck together end to end, I would expect the combined magnetic fields to be stronger in electrical fields between the two magnets, and I would also expect that the magnetic field configuration would overall just change. Thank you.